This is an eCat ASV about to hit the water for the first time. This is an initial shakedown run intended to get a baseline assessment of overall performance. This A14 cat is extremely capable. Its 14-foot roto-molded hulls and 80-inch beam provide a stable platform able to deploy up to 500 pounds of payload in Sea State 3 conditions. Propulsion is provided via dual-prop in-runner thrusters. These are foil-mounted with adjustable depth, allowing trailer launches in as little as 8 inches of water. Propulsion thermal management is by a simple and proven active single-circuit heat exchanger for the speed controllers with heat rejection via open-loop seawater circuit. The motor is directly cooled by seawater. This initial test and tune session is going well. The operations team is getting a sense of vessel agility and how it responds and behaves to input changes. The first assessments are conducted in manual mode using a standard handheld RC. Initial throttle limits are intentionally set to a fraction of full speed at the start of commissioning, then gradually increased once steering and throttle inputs become characterized. Switching over to auto mode lets the autopilot take control and the operator monitors waypoint following performance. During this process, and particularly with a cat, it's normal to have to tweak a number of turn rate controller parameters in order to obtain the best results. The desired turn performance is coming as close as possible to smoothly entering and exiting turns with a constant radius while maintaining speed, then following the next transect with minimal meandering or hunting across the line. These operations are best performed with the vessel fitted out with the full payload configuration. This can be done ahead of complete system readiness using sandbags and deadweights, but any drag-inducing sensors below the hull should be as close as possible to what will actually be deployed. The A14 can be fitted with a wide array of drag-inducing bathymetry gear, including full multi-beam systems and sub-bottom profilers. The payload for this mission is an underwater acoustic source. These have numerous applications advancing research in high-frequency ocean acoustic propagation, underwater wireless acoustic communications, and seabed characterization and classification. Below the hull, the sensor is fitted to a V-wing, a towed underwater depressor with a unique dihedral wing design. This enables minimum setback of the source behind the vessel, stability during operations, and steady depth control. Up top, all electronics, including system power, vessel nav and telemetry, and payload electronics, are enclosed in a topside pod. At the end of the test session, mission parameters are documented and configuration files saved. Once out of the water, the hull and cooling circuits are given a quick freshwater rinse, ready for the next deployment. This system is now ready for final instrumentation and pre-checks before being actively deployed. It'll have no problem carrying the 150 pounds of special missions payload fitted here, operating autonomously at 4 to 6 knots in 1 to 2 foot chop and 20 knot winds. And with its 96 amp hour onboard battery, which is only half of what can be carried, the fully loaded vessel can easily be run for 4+ hours before monitoring battery status becomes a consideration. To learn more, visit us at the links below.